Greetings to the respected lecturer and to all the fellow viewers. I'm Joel Nityanandan from Group 19. Today I'll be presenting topic 1, which is based on scheduling algorithm. And moving right into the presentation, topic 1, I'm required to create a question for scheduling algorithm and present the solution for the question. This is the created question, and I'm required to draw the Gantt charts illustrating the execution of this process using primitive SJF and non-primitive SJF. And given in table 1 a set of process with the length of CPU burst time in milliseconds, the process arrived according to the arrival time. This is the table which has the process, the burst time, priority and arrival time. Moving right into the primitive SJF, which is primitive shortest job first, I'm required to calculate the waiting time and average waiting time for the listed scheduling algorithms. And for primitive SJF, the process can be disturbed. So in which case, the process will start at P1, and the arrival time will be 0, burst time, arrival time 0, burst time is 9. Done. So P1, and the process will stop at 3 because P2 process comes in, process stops at 3, and you have to put process here, process 2, burst time is, arrival time is 3, and the burst time is 6, 3, 6. And the process is 3 minus 0 is 3 milliseconds, thus we have to minus here. 9 minus 3 is 6, and we have a new process. The new process will be P1 0, and 9 minus 3 will be 6. Now comparing this burst time for process 2 and process 1, since both of them have the similar burst time, we look at arrival time. The lowest arrival time is P1. Put P1 here, and the process will stop at 6. Process stops at 6, and thus a new process comes in. Process stops at 6, which is process 3. The arrival time is 6 and burst time is 12. 6 and 12, and we have to minus 6. 6 minus 3 is 3 milliseconds, thus 6 minus 3 is 3. And new process will be P1 0, 6 minus 3 is 3. Comparing this burst time, P3 and P1, the lowest is P1, so we put P1 here, P1, and the process will stop at we have to look at the lowest arrival time, so the process stops at P5, which is arrival time is 8. Process stops at 8, and new process comes in. Process stops at 8. P5, 8 arrival time, and burst time is 8. And then we have to minus 8 minus 6 is 2, thus 3 minus 2 is 1. This new process is the new process, come on, P1 0, and 3 minus 2 is 1. Process will stop. Comparing both of these burst time, the lowest one is P1 again, so P1 we put here, and the process will stop at 9. Process stops at 9, and new process comes in. P4 9 P4 7. Burst time is 7. That's this P1 9 8. 9 minus 8 is 1, and 1 minus 1 is 0. Process is completed. Thus we'll move on to the seeing the lowest burst time over here. The lowest is comparing the lowest is P2, process 2. So P2 9 plus 6 is 15, plus 6 is 15. Next process is P4, lowest next process is P4 7. So P4 and 15 plus 7 is 22. Next process will be process 5. P5 22 plus 22 plus 8. 22 plus 8 is 30, and the final one is P3. Process 3. 30 plus 12 is 42. Now calculating waiting time and average waiting time, we have to plus the current chart. All right, so we are calculating the waiting time for P1 is 0 plus 0 minus 0 equals to 0, and for P2 is 9 minus 3, and for P3 is 30 minus 6, P3 30 minus 6 arrival time, and P4 is 15 minus 9 arrival time, and P5 is 22 minus 8 arrival time, and we'll get 0 6 24 6 16. And to calculate the average time, we have to plus the answer and divide it with 5, and the answer will be 10.4 millisecond. So this is the answer for waiting time, and this is the answer for average waiting time. And yeah, moving on to the next question, which is non-preemptive SGF. So I've copy pasted the timetable, the table from just now, and moving right into the non-preemptive. Non-preemptive SGF, it cannot be disturbed. Thus, the first process will be P1. The arrival time is 9, and the burst time is wait. The arrival time is 0. The burst time is 9, and the process stops at 9. And the next is P2, and for non-preemptive SGF, we are looking at the lowest burst time. So P2 as the lowest burst time 6. So in thus process here, P2 3, arrival time 3, burst time 6, and the next is lowest burst time is P4 with the 7. P4 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 arrival time 7, arrival time P4 arrival time is 9. P4 arrival time is 9, burst time is 7, and 9 plus 7, wait, for P2 we have to plus with 6, so 9 plus 6 is 15, and for P4 after that the next process is P5 with the lowest is 8. P5 burst time lowest 8, and P5 arrival time is 8, and 15 plus 7 is 22. P5, and then the last process will be P3. 3 burst time lowest is burst time 12. Arrival time P3, arrival time 6. Thus, answer is 322 plus 3. 22 plus 8 is 30. And then process and share. Thus completing non-primitive SJF. This is the answer for the Gantt chart, and now I'll be finding the waiting time and average waiting time, which is pretty much the same. Copy, paste here, and since the answers are similar compared to the previous one, the waiting time, the calculation is similar. 0 plus 0 minus 0 is 0. For process 2, 9 minus 3, 6. Process 3, 30 minus 6. And process 4, 15 minus 9. And process 5 is 22 minus 6 minus 8 is 16. And we have to sum the answer sum up the answer and divide them with 5 to find the average waiting time. And the answer is 10.4 milliseconds. That's it. I'll end my presentation here. This is the answer for non-primitive SJF, and this is the answer for primitive SJF. Thank you. Have a nice day.